Today we are going to discuss several challenges related to human reproduction on Mars. First, we will discuss the key challenges, particularly in relation to differences in gravity and radiation.
So how is gravity different on Mars, and how would this affect the development of a fetus?
In space, there is essentially no gravity. On Mars, the gravity is roughly 38% of the gravitational pull on the Earth. This is considered microgravity, and microgravity is known to cause bone loss and affect the levels of fluid in the eyes and spinal cord, which one major issue of this is vision loss in fully grown adults, not even in fetuses. Studies have been done on fetal development in rats, geckos, sea urchins, and birds, and the viability was typically lower in each of these, and unusual abnormalities often occurred in the offspring, which is a concern for fetuses. And there's also concern that pregnancy could be much more difficult for the mother in space with microgravity present.
Are there any possible solutions to these issues?
One possible solution would be in vitro babies. It is believed that we could successfully perform in vitro by freezing the combined sperm and egg, and then when on Mars, be able to thaw it to develop the fetus. Another possible solution of this is gene editing. Our bodies were not made to survive on Mars, so if we became per se less human with our DNA, then it could be possible to reproduce successfully on Mars. Changing our DNA slightly may be possible to physically build our bodies to survive on Mars and to reproduce on Mars. And this could be done by using CRISPR technology.
What's next?
Now we're going to shift focus to discuss relevant studies previously conducted.
What have we learned about the possibilities here?
Several studies have evaluated the possible effects of spaceflight on reproduction. And the focus of these studies is very diverse, ranging from analyzing the effects of spaceflight on sperm production to sending pregnant organisms into orbit. And one study of particular interest is a 1979 experiment on board the Vostok spacecraft, which evaluated how rats mated in space. And when the rats landed back on Earth, there was very clear evidence that they had mated, but none of the female rats had delivered. And according to scientists, this is not extremely surprising due to the fact that rats are very sensitive to environmental perturbations. This is one study that yielded interesting results, but clearly rat sensitivity lends itself to some questions regarding how applicable their behavior is in predicting how humans will respond to time and space. Another study led by April Ronka in 1995 sent already pregnant rats into orbit. And while in space, the pregnant rats gained weight normally and appeared as active and healthy as a group of rats in the control group. However, differences between the experimental and control groups arose once the rats prepared to give birth. So further, the rats flown in space required nearly 100 contractions to birth their pups, while rats in the control group needed only half as many contractions to give birth. The researchers here suspected this difference arose because the rat's muscles weakened significantly while in space. And another study sent 2-cell mouse embryos into space aboard the Columbia. These embryos failed to develop while the Earth-based control embryos developed completely normally. And while this study was not successful, a group of Chinese scientists successfully grew mouse embryos in space in 2016. And this study is monumental, as most previous studies had rejected the idea completely that mammals could develop in space. And various other studies have also found that rat sperm production decreases significantly after spending time in space. Freeze-dried mouse sperm can produce embryos after spending 9 months in space, and that animals such as crickets or nematodes and fruit flies can successfully reproduce during spaceflight. And so overall, the findings of all of these studies are important in learning more about how organisms and their reproduction is affected by spaceflight. However, this short synopsis of a few studies displays how diverse these experiments are.
How can these studies be applied to humans so that we can learn more about human reproduction in space?
At this point in time, most studies have indicated that reproduction is either not as efficient or not as safe in space, or that reproduction is extremely unlikely in space. However, it may be a little naive to firmly conclude that human reproduction in space will never happen. The success of growing mouse embryos in space in 2016 is a great step forward and helps to leave the door open for future experiments that may propel humans closer and closer towards reproducing beyond Earth's limits. So overall, many of these studies cannot directly be applied to humans due to the significant differences among the tested animals' reproductive systems and that of humans. And so further research is definitely needed to fully understand the possibilities of human reproduction in space or on Mars.
Are there any experiments looking to be launched in the near future? Are these studies more applicable to humans?
Yeah, so a team based out of NASA's Langley Research Center is currently working on a project evaluating the long-term effects of partial gravity on mammalian reproduction. And this endeavor involves sending a mouse colony into lunar orbit enclosed in a rotating habitat that will be operated mostly autonomously. And this habitat is called MICE-HAB, short for Multi-Generational Independent Colony for Extraterrestrial Habitation, Autonomy, and Behavior Health. And this study is currently aiming to analyze the effects of partial gravity on a minimum of 3 generations of mice within 1 year. The goal is to continue the study for 10 years to truly understand the long-term effects. And inspiration for the MICE-HAB project partially stems from a human mission to Mars. The study aims to be completed by the end of the 2020s to help inform design decisions regarding a human mission to Mars. And so although this experiment has not yet begun, it is a step in the right direction towards developing a greater understanding of how humans might reproduce on Mars.
We are now going to look at the challenges associated with inbreeding on Mars.
Is incest or inbreeding a genuine problem that we need to keep in mind when colonizing Mars?
When starting a colony on Mars, we will face many challenges. One of these challenges will be ensuring that the population of any colony that will be reproducing on Mars is of the ideal size to avoid any inbreeding or genetic drift. If the colony is too small, there could be detrimental consequences to its longevity. Additionally, it would be difficult to create a very large population on another planet quickly, meaning that if we want to start truly colonizing Mars, we have to find the ideal population size that can keep genetic diversity high, but is still plausible given our resources and time. So yes, inbreeding within a Martian colony is a legitimate issue that must be solved sooner rather than later.
What possible negative outcomes of inbreeding could occur?
Inbreeding and genetic drift could have numerous negative impacts on a colony on Mars. Incest and inbreeding can lead to negative or even deathly recessive traits occurring commonly in the population. This leads to decreased fitness within the population, decreasing chances of survival and success. Additionally, a small population can lead to genetic drift. Genetic drift is a biological mechanism involving, quote, random fluctuations in the frequencies of alleles from generation to generation due to chance events. Genetic drift can cause traits to be dominant or disappear from a population. The effects of genetic drift are most pronounced in small populations, unquote. There are multiple examples throughout history of the negative outcomes of incest and inbreeding. One such example is found in the Habsburgs and Charles II. This royal family of Spain practiced inbred marriage as a political strategy for at least 9 generations, leading to Charles II. Charles suffered from infertility as well as numerous genetic disorders due to his incestuous family lineage. His, quote, inbreeding coefficient, a figure reflecting the proportion of inherited genes that would be identical from both parents, was higher than if he had been born to siblings, unquote. While this may be a dramatic example, it is applicable to colonizing Mars. Over many years, if the population on Mars is too small, similar issues that the Habsburgs faced could arise. This goes to show that we must be cautious while colonizing Mars. If the gene pool is too small, there could be life-threatening genetic mutations.
What is the best possible solution to this problem?
Researchers are beginning to find the ideal starting number of a community in order to prevent inbreeding and/or genetic drift. However, this is a hot topic and many scientists disagree on this number. Solutions range from only 98 people all the way to around 14,000 people. These numbers are, of course, incredibly different. First, astrophysicist Frederick Marin used a program entitled Heritage to estimate the number of healthy individuals required to start a human colony on another planet, resulting in the shockingly low number of 98 individuals in a colony. Marin took into account inbreeding and incest, epidemics, and other possible catastrophes that could occur during the journey or on the other planet. However, anthropologist John Moore refutes this number, stating that his research suggests that 160 individuals would better suit the goal of eliminating genetic drift and inbreeding. On the other hand, anthropologist Cameron Smith is doubtful that a population as large as 14,000 individuals could start a successful, healthy colony that is required to last hundreds of years. Such a population would provide some padding in the case of catastrophes that could result in significant loss of life within the colony. Due to the many differing opinions on the ideal population size, there is still a great amount of research that needs to be done, specifically surrounding the genetic impacts of radiation in space and on Mars. Hopefully, the number will be closer to 98 to 160 individuals, simply because starting a colony of 14,000 people or more would be incredibly difficult, if not impossible in a short period of time. Regardless of the starting size of the population, scientists advise the implementation of genetic screening of astronauts, looking for any possible recessive genes that could lead to negative genetic disorders within the colonizing population. Hopefully, scientists will be able to settle on an ideal number that is large enough to prevent genetic mutations and disorders due to inbreeding, but also is small enough to easily and quickly form a colony on Mars.
Are there any other problems we should further investigate, understanding human reproduction on Mars?
Differences in gravity and radiation levels on Mars can make it difficult or even borderline impossible to carry a pregnancy to term. We will now look at how we can use artificial wombs to solve this problem.
Can artificial wombs be created, or are they simply fiction?
Well, artificial wombs inspired many science fiction stories in the past. Today, they're very real. In fact, several studies are already into animal trials. As late as March of 2021, researchers have begun to experiment on creating a mouse by forcing oxygen and blood into mouse embryos. Another example is the creation of a lamb in the hospital in Philadelphia. While this is just a mouse and a lamb at the present, the technology could be expanded to include humans by the time we get ready to head to Mars. This technology is uncomfortable for some, but could be used to repopulate Mars in the distant future.
Are artificial wombs a good idea when trying to populate Mars?
Artificial wombs are one possibility among many. However, if the technology permits, scientists would be able to create human life on the surface of Mars. This could give it some advantage over other alternatives because multiple life forms could be created from a single pod. Therefore, it would require far fewer trips to create a sustainable colony on Mars. Essentially, having more people on Mars in the long run makes it easier to colonize. This would save NASA and other companies a lot of money and effort in creating a way for more people to go back and forth between Earth and Mars. However, this method would be more of a long-term plan because it would take decades to execute fully. While the technology would be ready by the time we are ready to go to Mars, it will take several trips to and from Mars to even begin to execute this plan. Artificial wombs would have to be considered a plan to populate Mars after a colony is already established, because most of the amount of time it would take to create life. In that respect, it is not a great plan to bring in the first few trips to Mars, but it would be an effective way to repopulate the planet.
Are there any moral issues related to artificial wombs?
Anytime there is a possibility of creating human life outside the typical maternal method, there will be ethical questions. Primarily, the question would revolve around whether the babies born from artificial wombs would be people in the same way that we are people. Another question would be whether the baby would miss out on some form of maternal cultivation. A baby would be missing out on the benefits of maternal influence, such as placental influence of hormones. While I do not know the answer to these questions, it is important to consider the ethical considerations involved in colonizing and reproducing on Mars.
All in all, it will be a tough road ahead for humans to be able to reproduce on Mars. With the differences in gravity and radiation, it doesn't appear that humans will be equipped to grow a fetus and raise a small child with current technology.
This certainly does not mean that it will be impossible. Recent research is trending towards the possibility of mammalian reproduction in space, and new technologies such as artificial wombs will certainly push us in the right direction.
On top of the issue of can we physically reproduce on Mars, we must understand how we can safely reproduce to avoid an incestual colony.
In conclusion, we must not yet rule out the idea of human
Is possible.
In conclusion, we must not yet rule out the idea of human reproduction and colonization
Colonization of Mars. With science and technology, anything is possible.